Wait. Where's the triangle?
On the
It's that point. Oh yeah, point's a triangle.
You just
Yes. Well, that
the
point can
angle
make a
and then
triangle if
straight
you
down.
believe.
Wait. Here's that point, right?
Go up and
But
straight
it's on
down.
the terminal
But it's a
side.
point on the terminal side, which means it must connect to the vertex, and this is the angle. This is the triangle. Now, we don't look at the obtuse angle. We look at the little baby acute angle that's formed with the horizontal, like what you guys have been doing when it's over here. You're like, oh, hey, it's 30 or 45 or 60. Look at that little angle. And we're trying to find his sine, cosine, tangent. Even though the big angle got us there, the little angle is what we're looking at. So how can we label our adjacent side? What would he be? -3. What would our opposite side be? 4. Hey, this is a 3, 4, 5. But if you didn't know that, how would you solve? A squared plus b squared is c squared and solve. So whose sine? SOHCAHTOA. Opposite over hypotenuse, which is?
4/5.
Okay, that's good. You guys beat me this time. What's cosine?
Adjacent cot.
Ka, right? Adjacent over hypotenuse. And then toa. What's the last one? Wait, why isn't it 4 over -3? Wait, a positive over a negative makes the whole thing negative. Just put the negative out. Are we good?
Yes, ma'am.
Okay, keep going.
Ooh, solving for
So, real quick reminder, even though we've kind of been doing it, because when we did the unit circle, we were thinking of this. Whenever you're solving for trig functions, you want to sketch the problem. When you draw a triangle to the horizontal axis, you never go to the y, you always go to the x. What do I mean? If you had this type of angle, the triangle would go down to the x. This type of triangle would go up to the x. This type of triangle would go up to the x. What am I never doing? I'm not going over. I'm going up or down, right? So when you form your triangle with an angle, this is your theta, but you're looking at this triangle for your ratios. This is your theta, but you're looking at this triangle for your ratios. And this is your theta, you're looking at this triangle for your ratios, which hopefully that whole, is it a 30, is it a 45, is it a 60, has already kind of gotten that in your mind. What are those little baby triangles, or I should say, the angles in those little baby triangles called? Reference angles. The actual little angles in the triangles are called reference angles. Sometimes they're supplements to an angle. Sometimes they're actually little parts of the angle. And sometimes, well, they are what would complete the circle. But either way, a reference angle is an acute angle. Underline that. He's the little one in the triangle formed by the other angle, whoever he is. And he's between the end of the angle and the horizontal axis, wherever the little angle ends. Okay, so new term, reference angle. So in the unit circle, I can restate some of the things we've been saying. I think I've even said it once or twice. For some of those angles in the second, third, fourth quadrants, when I've been asking, is it a 30, 45, or 60, I've been asking for the reference angle. The angle's bigger than that, but his reference angle is one of those basic 0, 30, 45, 60. Does that make sense, kind of? We'll see when we get to some examples, huh? Yeah. I'm trying to get you guys this unit circle quiz, so you'll get back tomorrow. I was going to throw them in for the grades, and then I was like, but my grades, they don't do the grades until today, so then I was going to put them in my this unit. Are we done? Do anything fun for your birthday, Luca?
Probably on the weekend, but
Just school for right now, huh?
yeah. I mean, my parents told me 12:30.
They wake you up,
No, I was expecting it.
but you were tired.
Yeah, I was doing college stuff, and then they called me.
I'm glad they called.
My mom was like really sad.
Because you're not home for your birthday.
Yeah,
That's a sad thing.
like it's the third one. Anyways,
But you're hanging in there.
nothing. Don't make me think about it, dude.
Alright, let's keep going. Alright, so, solving for trig functions. You just wrote down just a second ago, you want to set up a triangle with the reference angle. What does that mean? Okay, I just saw it. Why am I saying watch out for signs? Why am I saying watch out for signs? You sketch the angle first. You make your little triangle second. Your reference angle is a little one that we've already talked about that's in between. You look at the opposite and the adjacent and the hypotenuse, but why am I saying watch out for signs?
Because let's say if you need to solve for the hypotenuse, you shouldn't really use the negatives in there, but when you come out of that, you should make sure that your opposite, like your different negatives should still be in the equation for solving for sine, cosine, and tangent.
Good. So when you're doing your trig, the hypotenuse, hypotenuse should always be what?
Longest.
Longest and positive. Hypotenuse is always positive. It's just the radius. It's just how far out. That's all that means. But everything else, the x and the y, as we've already talked about with the unit circle, has meaning as far as signs, right? And in the second quadrant, we've already talked about this. What would this point have as far as signs? What should it have? A negative for the x, right? Because it's left. And then what for the y? Positive, right? And our silly way of remembering it is all students' signs should be positive and hence cosecant, but not the rest. But couldn't we also just label the adjacent with negative and label the opposite with positive, and then it'll just work out when we do our SOHCAHTOA HonorPrecalc, right?
Yeah.
Okay, something to think about. Solve for the appropriate trig functions. We could write SOHCAHTOA HonorPrecalc all over again, but you guys already have it in your notes. Is that cool? Okay, let's get to an example.
We're not going to use those when we're using like the length of triangles, right?
Yeah.
Because you can have a negative length.
Right. So it's only when we're asking for trig, what trig equals. We're not necessarily talking about the actual lengths in like a real life problem.
Okay.
Because a real life problem, we could put the triangle like in the first quadrant, and then it would all be positive. So if they just were asked to ask for reference angles, the first thing we have to do is sketch, right? Where's 300? Just think by nines. 9, 90, 18, 180, 27, 270, somewhere right here, right? How am I going to find the reference angle? Now this one's hopefully kind of easy, but how would you find it? You would say, hey, it's going to be, what's the whole way around? 360, and who am I subtracting? 300. So who's my reference angle? 60. We'll call reference angles alphas. How about that, just to keep it consistent? Now, why am I making sure you know the idea? For the next one. Is that 2.3 degrees?
No.
Why not? There's no degree mark. Oh, but there's not a pi. Where's 2.3? Now, we could try to convert and go to degrees if we really, really needed to, right? But if we can figure out about where he is, maybe we'll be able to do this thing. Question. We know this is pi, and that's 3.14 is less than that, right? Okay. What's this one? Pi over 2. What's pi as a number? 3-ish. 3 over 2-ish is 1.5-ish, a little bit bigger. But still, where's 2.3 if that's 1.56?
He's all
He's
over.
over here, yeah?
Yeah.
So if he's over here, we can draw our angle, even though we don't know exactly where he is. What math would I use to get him all the way?
5 minus
Subtract
90
Who's
minus
there?
2.3.
Pi, and who's up?
That's stuff.
2.3. So I'm going to do pi minus 2.3 to solve for alpha. Struggle. My alpha suddenly turned into like a, I don't know.
Also, it's gotta be in the second quadrant because, like, you can have a reference angle of an acute angle.
Yeah, not really, right?
So you,
Because Luke is like, well, if it was first quadrant, it would be its own answer. There wouldn't be any extra referencing. That's true. 2.3 is just an angle. Remember when we did radians and I made that whole little ruler thing of radii? So I was like, hey, here's the ruler, 1 radius, 1 radius, 2 radii. So on our little ruler we have little tick marks, right? When we went to go wrap, 2.3 would be just a little bit past 2 of those, if that makes sense. But it's like the arc length, remember? So then alpha would equal, now guys, I have no idea what this would be and I don't want you to go to your calculators, so we're just going to write pi minus 2.3, whatever. Who wants to go to decimals after that? That's an alpha, sorry, not a D. How about letter C? What quadrant is negative 135 in? Ooh, angles can go negative. We haven't done that with our unit circle, but we can. Negative 90, negative 45 more. Does that make sense? So negative 135. Who's my reference angle? So we would do, if we needed to do the math, 180 minus 135, and he's in degrees for our little alpha, but he ends up just being 45 degrees.
the reference angle is also never negative.
Never negative, always positive. Good. Never negative, always positive. Do we get the idea of reference angles? Get a picture, figure out what you're finding, and then you can make that subtraction, which is especially helpful when it's something messy that we can't just do really quickly in our class. Almost. Okay, let's see if I have any more examples up my sleeve. Wait a minute. Oh my goodness, it's like I'm making you practice more. Oh my goodness. Okay, question. Where's 4 pi over 3?
It's in quadrant
1 and a third. Right? Good. Quadrant 3, 1 and a third. You guys get that? 1 and a third.
Oh, I see it.
You see it? So 1 whole half circle and another third. What's his reference angle?
60 degrees.
It's a 60 degree, right? So if we're thinking cosine in our table, he's the second one, and then 3, 2, 1. Ah, 1 half, what? It's in the third quadrant, so what sign? Negative 1 half. If you're thinking just spatially, you go left, negative, left a little, negative 1 half. Now, for the next one, negative 210, where's that put us? 90, 180. Yeah, how much though? 30, right? So go 90 down, 180 down, but I need another 30 to get to 210, so another 30. So my reference angle is 30. Tangent of a 30. Right? But what's my,
I like that.
but what's my sign?
It's negative.
Because remember, in this quadrant, I'm going to have a negative x and a positive y. Tangent is positive over negative, which means a negative. If you guys are unit circlers, you would probably do negative root 3 over 2 over 1 half. What happens to those? Wait, sine over cosine. I keep doing that. Second time today. Struggle. Sine 1 half over cosine negative root 3 over 2. The over 2's cancel. Ooh, I need to rationalize times root 3 over root 3. There we go. Does that make sense? Alright, you guys, let us see go. I've been talking too much. You guys go. 11 pi over 4. Stand on your own two legs. Here we go. One or negative? The beginning calzone is going to mix a number. 11/4 times pi. If you're counting around, just keep counting until you get to 11. Are you counting by? What'd you get?
2 square root of 2 over 2.
Yeah.
So square root of 2.
And it's positive 13 seconds.
That's the math you did, right? Now, hold on. We've been doing a lot of the whole calzone thingamabob, and a calzone thingamabob, you would have thought of this as 11/4 of a calzone. You would have changed that to a mixed number of 2 3/4 calzones, being half circles. But I haven't done much of the whole count by 1/4 thing. What's the fourth of a pie? Ready? Ready? 1/4, 2/4, 3/4, 4/4, right? 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4. I got this. Same place that 2 3/4 would have gotten us. So however you do it, whether you count by 1/4, whether you turn 2 3/4, or whether you're one of those snazzy people that are like, yeah, I just hate radians this much, so I'm going to go ahead and multiply by 180 over pi, and say that 4 and 180 is 45s, and we have 11 45s.
It's, degrees are nice until you get to 360.
Yeah, then it gets messy, right? But you could go 11 45s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, 2 pi, remember? 2 pi
Oh,
is
yeah,
just
yeah, it's just
and then so 2 calzones. So 1, 2, 3/4. Anyway, that would have gotten you to 360 plus 135, right? Which would have been 495. I think that's right. Yeah, 45 and 450. Anyway, that's how Karina was able to get to the second quadrant, and she knew the point was negative root 2 over 2, root 2 over 2. Sine is this one, cosecant is 1 over sine. We're done. Kiddos, what's tonight's homework? Well, the unit circle. Oh, sorry. What? The unit circle quiz.
Yeah, well.
So you and I are dumb thing. It's so hurtful.
Sorry, wrong unit. We already did that. That's getting intense. Okay. So, homework 4.4 due tomorrow. I'm going to go ahead and get you guys the homework assignment because most of you have not written it down since we didn't really do it till today, yeah?
Yeah.
All right, open up your spiral. Let's write down the assignment. Sounds like a Christmas song. Christmas is way too early this year. Or at least them making everything Christmas. Here we go. There he is. You guys see him okay? That's an old song. What are the first two homework problems?
The first two homework problems are 8 and 9A.
Okay.
Where did you go to college?
You guys have them all written down? 5, 4, 3, 2? Wait, guys, hold on. We still have like what? Almost 5 minutes?
Yeah, let's bang some out.
Ready, set? There you go.
Oh, thank you.
There's 8 and 9A.
See, where'd you go to college?
Number 8.
My friend from Brazil wants to go to masters. My friend from Brazil wants to go to masters.
Play soccer?
No.
Just to go.
Yeah.
It's a
He
good school. I love it.
never studied here or anything, and he got a 1350 SAT. So like,
Like on the math and English part, yeah.
he's getting like a lot of scholarships.
I enjoyed masters. A lot of money. Back when I went, it was more affordable because there was more financial aid. They didn't have to raise their prices.
He wants to do business and minor theology.
And Kayla's, well, I don't know. There's a few seniors that I think are
No, Kilamon. I was good person, I don't want to play sports in college. No, I want to focus on
Well, you want to hear big goals.
and I still want to do a minor international business, and even maybe go to Christian college and I'll do a minor in theology, or maybe take like some weird Buddhism treat. That's why.
Talk to Mr. Carter.
Mr. Williamson told me that's a really good idea. That's why he wants to tell his son. Say either Hebrew or Greek.
Well, because English, well, I mean, you know more languages than English, but English is so like kind of cut and dry, whereas Greek and Hebrew, like one word, there are so many different forms that show so much more
Like
meaning
love.
as to what's going on. Yeah.
There's love heroes.
There's like mankind, all man, my male.